Sometimes I give kind of strange looking questions. Find the derivative with respect to t of, say, the magnitude of r of t, oh, I don't know, to the fourth power or something like that. The answer is not the magnitude of r of t to the the answer is not 4 times the magnitude of r of t to the third power, right? That's probably what people would guess, but it's not right. Got some relationship to the right answer, but it's not the full right answer. What's the way to figure this kind of thing out? You need to realize that the magnitude of a vector to the fourth power, since the magnitude of a vector squared is the vector dotted with itself, the magnitude to the fourth power is going to be the vector dotted with itself squared. That's what you need to realize. And then after that, you need to use the chain rule for derivatives to do this and this. I brought the 2 down, subtracted 1. There it's okay, because this is a scalar valued function right in here. A scalar valued function. What I just used is the ordinary chain rule from calculus 1, even though I'm using it with vectors and a dot product. This function takes numbers t for input and gives you numbers for output. Yes, it's written with vectors and a dot product, but it is a scalar valued function that you can apply calculus 1 methods to, and I just used the chain rule. But I'm not done, because I need to differentiate this too with the product rule for dot products that is in our textbook in chapter 11, I think, section 11.2. So I got 2 r of t dotted with itself times the derivative of this is a product, quote unquote, of 2 functions, 2 vector valued functions. It's a dot product. There is a product rule for dot products. It's going to give you r of t dot r prime of t, the first function, dotted with the derivative of the second, plus the derivative of the first function dotted with the second. That's a product rule that I just used. Can this be simplified more? Yes. R of t dotted with itself is the magnitude of r of t squared. That's one way it can be simplified. And these 2 things are the same. I can combine these to say that's 2 r of t dotted with r prime of t. And then in the end, 2 times 2 is 4. I can write 4 times the magnitude of r of t squared times r of t dotted with its derivative. That's about as simple as you can get it. That's the answer. Crazy, huh?